Hi, my name's Ian Carroll, and I'm a crafter at 8th Light. I'm going to be giving a talk on deep learning AI. This is A View from Orbit. This is coming from this book, by the way. If you haven't read this book, it's a very good book. I haven't really actually entirely read it myself, though. I've only read the first few chapters, but I found those so interesting that I wanted to give this talk. In any case, this gets into a question about deep learning, which is, to begin with, what is code? Well, this is actually really simple. Code is just rules. That's all it is. It's just rules for the computer to do. And how this works is a computer takes data, gives it to the code, something happens to the data inside the code, it sends out answers on the other end. That's it. Now that means that basically code is rules. Data in, rules happens, answers out. That's it. Code as we know it. But that's incomplete. That's not all that code actually is, because we've forgotten a really essential part of this equation, which is the human being, or in this case, the half-human being. But in any case, yes, the human being is part of this system, and we need to acknowledge that. How that happens for us at 8th Light is we use TDD, test-driven development, in order to write our code, create our rules. That's what we are doing. We are creating rules. So how we do that is we put in certain kinds of data that we want to test. This is stuff that's going to be tested input, and then we're going to get expected output. We're going to use a test, and we're going to ourselves look at the test, see whether or not the test has passed, and change the rules until that test passes. We can also then perfect the code after that in order to create refactoring and to make really, really high quality code. So this is really essential for writing good software. So yes, the crafter takes test data and expected answers, puts them through TDD to create the code or the rules that is then used in production. This is very much like a deep learning AI. The difference here is that the crafter would give it training data and training answers, and the deep learning AI would come up with the rules. So unlike regular code, where you have data in, rules happening, it producing answers, here you have the data and the answers to begin with. And the deep learning AI's job is to figure out what the rules are. This is code, but not as we know it. So here's an example of how this works. Say that you have a deep learning AI and its job is to figure out numbers, handwritten numbers, and to be able to identify them with what they are. That's what a lot of deep learning AI is about. It's going like a computer going, hey, that's a bird. That's a fire truck. That's a kitty. But in this case, we're just going to say, have the deep learning AI tell us, hey, this is a number 2. So this is a complicated way of saying this is a number 2, but actually this is very, very powerful stuff. So in any case, for this example, you have a sample, which is like a JPEG or a GIF or something like that. And then you have a label, which is going to be a data type, usually going to be an int, or perhaps a float, depending on what it is. Probably in this case, it's definitely an int. Anyway, that's beyond the point. So that means we have some new vocabulary to learn. We'd have training samples and training labels rather than training data and training answers. That's going to make it seem much more sciencey. So yeah, that's good. So yeah, this is data science after all. So beyond that, we also have classes. Now, in any one of these samples that we get, we're going to have a series of classes. These are buckets that it's going to go into, one of these. So just like with science, where you classify animals into whether it's a fish or whether it's not a fish, here in this case, we're classifying our writing samples into which one of these numbers it is. This assumes, of course, that the writing sample is a number. So the objective here is to classify each sample by labeling it. How the machine learning algorithm does this, how the deep learning AI does this, is by using layers. Now these layers are what is commonly referred to as a neural net. This neural net has nothing to do with what biologically is a neural network in a human or an animal's brain. It is inspired by that, but it's so different and we understand the brain so little that I can't really say that this is anything like a biological organism. For a little while, I was actually seriously worried that we were creating living things. But now, don't really think so. It's really just a very complicated computer program. So here's how this works. you put in the training samples and the training labels that go into the deep learning AI. So for each sample, let's say that you have a sample that's a JPEG of a handwritten tube. That goes into layer 1. Layer 1 transforms that JPEG in some way or another with some weights. Then it sends it to layer 2. Does the same thing. Layer 3 does the same thing. It keeps doing that. It'll do that for like 100 or so layers. That's what the deep in the deep learning means, is that you're transforming it a lot. Until eventually you get down to the very end where it produces a label. It has decided what that is. Now, these weights to start with are randomized. So the chances of you getting the correct answer, of this algorithm getting the correct answer from this first try, are really, really tiny. Most likely it's going to be wrong. It's going to say like 6 or 4. It's only going to say one of the numbers. At least it can't say pineapple or something like that. But that's what's going to happen. So how do you make it right? Well, that's where the loss function comes in. So the loss function is going to compare the label that came out the other end of this algorithm and compare it to the training label that it got of what it should have. And it's going to compare those two and create a loss score. That loss score is going to be then taken to an optimizer with something called a backpropagation algorithm. And it is going to adjust the weights on each of those layers, or in some way, until it gets to the point where it is guessing correctly. Now, it'll go through these training samples, and usually you're talking about a sample size of somewhere around 10,000 or more. You're not going to be able to figure this out with just a few. And even if you did, you would probably bake the algorithm in a way where it can only answer those few questions and not answer any actual production ones. And that is something that you need to worry about with a deep learning AI, and when you're training it, not to train it too hard, and not to train it with too small a sample size, because if you do, it will only understand how to identify its own training data and no actual production data. Here are some things that deep learning AI is used for. For one thing, image classification. You can use it for speech recognition, handwriting transcription. You can also use it for machine translation, although not perfectly, still working on that. Text to speech, speech to text, digital assistants like Amazon Alexa. Also autonomous driving like your Tesla or anything else of that nature. Also ad targeting. Ever had those cases where you went to a website and then found the products you looked at followed you around afterwards? That's the deep learning AI. Also search results, very good for optimizing those, and also, of course, for mastering Go, probably the most complicated board game that has ever existed. So yes, it can even do that. So what else could you use deep learning for, though? Because those are only a few things that it's used for right now, but there are so many things you can use it for. One thing in particular that I found interesting was to use it as a development tool. So what the crafter would do is use a deep learning AI to write the basic code. So as a development tool, the crafter would write test input and expected output, put it into the deep learning AI. The deep learning AI produces the code or the rules that are then placed into the app. All the developer then does is name the code, label what it is, and places it into the app. Now, in order to do this correctly, you would need to make sure to understand solid principles. You'd need to understand how to write clean code in the first place. Otherwise, you would make an incredible mess that you would never be able to figure out, and the only way to deal with your problems would be to burn the whole thing down to the ground and start again. That's not a good way to develop code. Instead, you should make little tiny swappable parts. So those swappable parts, you'd be able to pull one out and put a new one in when you need to. But this way, you can actually let the deep learning AI optimize that code for you. And your job is now to apply the name for it and make sure that you can come back in there and switch it for something else if you need to. Or even, for that matter, handwrite your own. That would be possible in this case. So that's another interesting thing you could do with it. In any case, that's the end. So thank you guys very much. Thank you for listening to this talk. I hope you had a great time. Hope you learned something. And I'll see you around. So thank you. Okay, are we done? Okay, there's something I need to tell you. Machine learning is